Okay, so we're back after looking at the graphs again a little more in depth. When we looked at the graphs, we discovered that at 3, what we ended up having happen is we ended up having our graphs split again. And so it looked something like this at 3. And so as a result, that is what we call a non-removable discontinuity. So that is one part of your answer. So x equals 3, no, it is not continuous, it is non-removable. Okay, the second part of your answer is what happens at -3. 1, it's not continuous again. And then when we graphed it, what ended up happening on our graph is we got something like this. Okay, now you're wondering, well, how would you graph that? Actually, what ends up happening is if we were to write that graph down, that's how it would look like. We would put an open circle there. And that graph, we know, is classified as a removable discontinuity because what I could do is I could take my dot and do that and remove the discontinuity. Now real quick, x squared minus 9. What do you know about x squared minus 9? Is there a way I can factor x squared minus 9?
Oh yeah, it's a perfect square.
Ah, it's the difference of 2 squares. How will that factor? X plus 3, x minus 3. So real quick, if I were to solve my denominator here, and this is just kind of a side note, this would give me a value of 3. What would this give me? -3, right? So let's look at this. What do I notice about both the top and the bottom in that? They each have an x plus 3, right?
Yeah.
So that means you can do what?
Cancel.
Cancel. What's another word for cancel? Delete. Keep going.
Remove.
Remove. So if I take that x plus 3, I get x equals -3. That is a removable discontinuity because you have removed that factor from the equation. So that's where this removable, that's how algebraically you can find it. We're not going to worry about that too much, but that is how I could look at that and determine. This one I can't cancel, so this one is non-removable.
Awesome.
Okay? Alrighty, let's look at this one. We're looking at x equals -3. So at -3, let's start with the top one. We'll call this purple. So the first thing you're going to do is you're going to plug in -3. So at -3, what value do you get there? What do you get? -11. So here's -3. 1, 2, 3, 4, 5, 6. Crud, we'll have to go by 2's. We'll go this one by -2's. 2, 4, 6, 8, 10. So 11 would be right here. I'm going to go ahead and use an open circle because 11 is, our -3 is not included here. Okay, so greater than. Next one I'm going to plug in, let's plug in -2. What do you get at -2? Try again. -2, if I plug in -2 here, guys. 3 times -2 is? -6 minus 2 is? 2, 4, 6, 8. What happens at -1? -1 is what? -5, I believe. So what's this look like it's going to be? 9. Okay? That's the top part. Let's look at the bottom part. F of x equals 2 minus x if x equals -3. So at -3, what value do you have? 5. 1, 2, 3, 4. Well, so I have to go by 2's though. So 2, 4, 5. So here would be 5. Now I include this point.
No, that would be 6. Wait,
2 minus -3.
No, but are you just going by?
2, 4, 5.
Oh, my bad.
Okay,
Keep going.
-4. What's -4 going to be? Now you're right. -4 is going to be 6. -5 would be 7. So this part of the graph is going to look like this. Is it continuous at -3?
No.
It's not continuous. What type of discontinuity? What is it? Non-removable or removable? Non-removable. Okay? Alrighty, so what I'm going to do is we're going to come back to this one tomorrow. What you can do is go ahead and start, because we'll talk about end behavior. You can go ahead and start your assignment. It is going to be found on page 30 through 31. Now if you turn to page 30 through 31, okay, the first ones you have 2 through 10 to evens. That's just determining whether it's continuous at the x values what you need to do is do it exactly as we did it. The only change in the directions is that it says if discontinuous, identify the type of discontinuity as infinite, jump, or removable. Wrong. If discontinuous, I want you to identify, don't write this in your book, but identify it as either removable or non-removable. So just exactly what we went over in class. Okay, 14 through 20 to evens. That is something we will get to tomorrow. And then 21 through 31, that is we will get to tomorrow. So what you can do for tomorrow is the 2 through 10 to evens, 5 problems. Okay?